This Rust code snippet imports various components from the Midpoint engine crate, which is likely a game or GUI development library focused on animations and UI design. Here's a breakdown of the key concepts. 1. Modules and components. Midpoint engine animations motion path. Imports types related to animation motion paths, including easing type and skeleton motion path. Midpoint engine Floem. This module contains various submodules for handling events. Reactive programming, layout, painting, styling, and UI views, indicating a comprehensive framework for building interactive applications. 2. Event handling, event listener, and event propagation suggest functionality for managing user interactions through events, clicks, movements, etc. 3. Reactive programming, create RW signal, signal get, and signal update denote a reactive signal system for managing state changes in UI components. 4. Layout and style. Classes like Compute Layout CX, and Style are involved in calculating the layout and applying styles to UI elements, indicating a system for responsive design. 5. Graphics and rendering. Components like Brush, Color, Line, Point, and Rect specify graphics rendering capabilities for drawing shapes and coloring elements, while Renderer handles the overall rendering process. 6. Animation. The Animations submodule reflects a focus on animated transitions, with imports like animation data and UI keyframe likely facilitating the creation of animated keyframes in UI. 7. Time management. The STID time duration module indicates the potential management of timed events or animations. Overall, this snippet sets up a framework for creating an animated keyframe timeline, where UI elements can be positioned and animated over time, responding to user interactions and changes in state through a reactive programming model. This Rust code snippet defines the state management for a timeline component used in an animation context. 1. Timeline state struct. This struct encapsulates the state of the timeline, containing current time, a duration representing the current position in the timeline. Zoom level, a F64 indicating the level of zoom applied to the timeline view. Scroll offset, a F64 reflecting the horizontal scroll position of the timeline. Dragging, an optional field of type drag operation, not defined here, potentially used to manage drag and drop actions. Hovered keyframe, an optional tuple storing the name of the keyframe and its associated time, aiding in displaying hover effects. Property expansions, a hash map from the IM crate for immutable structures that tracks which properties are expanded or collapsed, using a string as the key and a Boolean for the state. Selected keyframes, a reactive signal, RW signal, that holds a vector of UI keyframe instances representing the currently selected keyframes. 2. Keyframe ID struct. This struct uniquely identifies a keyframe based on property path, a string that denotes the property to which the keyframe belongs. Time, a duration indicating when the keyframe occurs in the timeline. Drag state enum. This enum describes various states for drag operations. Keyframe, keyframe ID, indicates dragging of a specific keyframe identified by keyframe ID. Time slider F64 represents dragging of the time slider with the position indicated by a F64 value. Scrolling start X F64, start offset F64, manages a scrolling operation storing the starting X coordinate and the initial scroll offset. Overall, this code snippet is structured to effectively manage the data and interaction states needed for a timeline UI component, including keyframe management and user interactions such as dragging and scrolling. This Rust code snippet defines a configuration structure for a timeline component. Timeline config struct. This struct holds various configuration parameters for the timeline, including width, the total width of the timeline, height, the total height of the timeline, header height, the height of the timeline's header, property width, the width allocated for property labels or fields in the timeline, row height, the height of each row in the timeline, offset X, the horizontal offset for positioning elements within the timeline, offset Y, the vertical offset for positioning elements within the timeline. 2. Default trait implementation. The default trait is implemented for timeline config, providing a way to create a default instance with predefined values. Width is set to 800.0, height to 400.0, header height to 30.0, property width to 150.0, row height to 24.0, and both offsets to 0.0. This structure and its default implementation establish a fundamental layout for a timeline UI, allowing developers to easily instantiate it with sensible default dimensions. This Rust code snippet defines a timeline grid view struct and its associated implementation. 1. Timeline grid view struct. This struct represents a grid view for the timeline with the following fields. ID, a view ID that uniquely identifies the view. State, a reactive signal holding the current state of the timeline state. Config, a timeline config instance determining the layout and dimensions of the grid view. Animation data, a reactive signal that optionally holds animation data. 2. Constructor implementation, new. The new function constructs a new timeline grid view instance, accepts initial state, configuration, and animation data as parameters, initializes ID with a new view ID, creates a reactive signal from the provided state using createRWSignal, clones the configuration for internal use, initializes style with a set of styling attributes, including margins, position, and dimensions based on the config. Overall, this code snippet provides a robust setup for a timeline grid view, encapsulating its state, configuration, and styling in a well-defined structure. This code snippet contains two main parts related to handling events and rendering in a timeline grid view. 1. Event handling. The onEvent method sets up a listener for pointer movements, pointer move. When a pointer move event occurs, it prints event received to the console and specifies that the event should continue to propagate. Event propagation continue. 2. Drawing property label. The draw property label function is designed to render a label for a given animation property. It initializes a text layout for layout management and a list of attributes, adders list, to style the text, color black and font size 12 point. The indentation for the label is calculated based on the number of slashes in the property's path, multiplying the count by 15.0 to set the visual hierarchy. A prefix, either jet or phi, is added based on whether the property has child properties, reflecting its expand collapse state. Overall, this snippet demonstrates how to handle interactive pointer events and visually present animation properties in a hierarchical manner within a user interface. This code snippet continues the rendering process for a timeline component, setting text and drawing the property label. If the property has children, a prefix expand collapse indicator, or hat, is set. Otherwise, it assigns two spaces. It formats the property name with the prefix and sets this text into a text layout with the provided styling attributes, adders list. The text is then drawn using the cx.drawText method at a calculated position, factoring in indentation and vertical placement. 2. Drawing the time grid. The drawTimeGrid function retrieves the duration of the animation in seconds and calculates the step size based on the current zoom level, ensuring a minimum step of 0.1. It iterates over a range of time values, converting them to x-coordinates using a time-to-x function that likely translates timeline duration to pixel coordinates. The commented out code suggests there may be a subsequent drawing of vertical grid lines using cx.stroke, indicating that the grid structure for the timeline is about to be rendered. Overall, this snippet handles both the visual representation of animation properties and the layout of a time grid, crucial for displaying keyframes in an intuitive manner. This code snippet is part of the rendering process for a timeline component. 1. Drawing vertical grid lines. It creates and draws vertical grid lines on the timeline using the lineNew method, which defines a line from a calculated x-coordinate down to the bottom of the timeline with a gray color. 2. Drawing time labels. It creates a set of text attributes, adders list, for the label, setting the text color to black. A text layout is initialized, and the time value, formatted to 1 decimal place and suffixed with S, is set as its text. This time label is then drawn at the calculated X position at the top of the timeline. 3. Drawing keyframes. The drawKeyframe function prepares to render keyframes at a given center point. A size of 6.0 is defined for the keyframe, and its color is determined based on whether it is selected, using RGB values for blue if selected or orange otherwise. Overall, this snippet efficiently handles the drawing of both grid lines and time labels for the timeline, along with a method for rendering keyframes. This code snippet is responsible for drawing a diamond shape for a keyframe within the timeline component. 1. Creating a diamond shape. A Kerbo Bez path is constructed using a vector of path elements defining the vertices of a diamond shape. It starts by moving to the top point of the diamond. It uses line2 to draw lines to the right, bottom, and left points, completing the shape with close path. 2. Positioning. The shape's position is adjusted by adding the offset X and offset Y values from the configuration, ensuring it is correctly placed in the timeline. 3. Filling the shape. The diamond shape is then filled with a specified color using the cx.fill method. Overall, this snippet encapsulates the rendering of a visually distinct keyframe as a diamond shape on the timeline, enhancing user interface feedback. This code snippet includes two functions, draw keyframes and draw property keyframes, that are responsible for rendering keyframes for animation properties within a timeline interface. 1. Draw keyframes function initializes a variable current y to track the vertical position starting at the header height. Iterates over the animation properties retrieved from animation data. For each property, it calls draw property keyframes and updates current y based on its return value, if applicable. 2. Draw property keyframes function accepts the current drawing context, a reference to an animation property, and a starting vertical position, start y. It checks if the calculated current y exceeds the height of the view, returning none if the property is not visible, which prevents unnecessary processing and rendering. Overall, these functions manage the layout and rendering of keyframes for various animation properties, ensuring that only visible properties are processed and drawn efficiently. This code snippet focuses on drawing the keyframes for a specific animation property. 1. Retrieve selected keyframes. It obtains the currently selected keyframes from the application state. 2. Iterate over keyframes. It loops through each keyframe in the properties list. For each keyframe, it calculates the x-coordinate based on the keyframe's time using the time-to-x function. Visibility check. The code checks if the calculated x-coordinate is outside the visible area, less than -10 or greater than the width plus 10. If so, it skips drawing that keyframe. 4. Drawing the keyframe. It determines if the keyframe is selected and calls self.drawKeyframe to render the keyframe at the calculated position, adjusting the y-coordinate for vertical alignment. 5. Connecting lines. It checks for the previous keyframe that falls before the current one, and if found, prepares to draw a connecting line between them. The actual line drawing is not shown in this snippet. This snippet illustrates the process of visually rendering keyframes, including visibility checks and the rendering of connecting lines for a better timeline representation. This code snippet continues from the previous loop and handles two key functionalities related to rendering keyframes. 1. Drawing connecting lines. If the previous keyframe's x-coordinate, prevx, is within the visible area, greater than or equal to 10.0, it draws a dark gray line connecting the previous keyframe's position to the current keyframe's position. This is done using the cx.stroke method with a line segment that represents the connection. 2. Drawing the property label. After finishing the keyframe rendering, it calls self.drawPropertyLabel to render the label for the current property at the specified current y position. 3. Updating y position. The current y variable is incremented by the height of the row, preparing it for rendering the next property. 4. Expanding child properties. There is a conditional check, not fully shown, that determines if the current property has child properties to draw, based on the property path and the expansion state. Overall, this snippet efficiently handles the drawing of connecting lines between keyframes and managing the rendering of property labels, while also preparing for potential child property rendering. This code snippet completes the rendering of child properties for a given property in the timeline. 1. Conditional expansion check. It checks if child properties for the current property are expanded if the expansion state was set previously. 2. Rendering child properties. If expanded, it iterates over each child property, drawing each child's label and keyframes using self.drawPropertyLabel and self.drawProperty keyframes, respectively. If a child's keyframes are successfully drawn, i.e. if they fit within the visible area, it updates current Y for vertical positioning. 3. Breaking on visibility. If a child's keyframes are outside the visible area, the loop breaks early to avoid unnecessary rendering of subsequent children. 4. Returning current Y position. The function returns the updated current Y value, indicating where the next property or element can be drawn. Y position calculation function. The snippet also introduces a getProperty Y position function that initializes a Y position based on the header height and contains a nested helper function, findPropertyY, for recursively searching through properties to calculate the Y position for a specific property path. Overall, this code manages the conditional rendering of child properties while maintaining vertical layout positioning for the timeline interface. This code snippet is part of the helper function findPropertyY, which is designed to find the Y position of a specific property in a hierarchy of animation properties. 1. Check for match. It checks if the property path of the current property matches the target path. If it does, it returns the current Y position. 2. Incrementing Y position. If there is no match, it increments the current Y by the specified row height, moving to the next row for the next property. 3. Checking for expanded properties. It evaluates whether the current property is expanded and has children. If so, it recursively calls findPropertyY on the children to continue searching for the target path. The snippet efficiently traverses a tree-like structure of properties, updating the Y position and looking for a specific property path. This code snippet concludes the getPropertyY position function, performing the following operations. 1. Calling the recursive function. It invokes the findPropertyY function, passing the list of properties, the target property path, a mutable reference to the current Y position, row height, and the map of property expansions. Handling the result. The function captures the returned Y position. If a matching property is found, it retrieves its Y position. Otherwise, it defaults to the original Y position. 3. Final position calculation. It adds an offset Y, from the configuration and adjusts the resulting position vertically with half the row height, ensuring proper alignment for rendering the property. Overall, this snippet finds the Y position for a specific property within a given configuration and handles cases where the property may not be found. This code snippet contains 2 key components. 1. RequestRepaint method. This method calls requestPaint on an ID associated with the object, signaling that a repaint of the UI is needed. It typically implies a change in state or user interaction that requires visual updates. 2. HitTestKeyframe function. This function checks if a given point in the UI corresponds to any keyframe in the animation timeline. It initializes the vertical position, current Y, and iterates through each property in the animation data. For each property, it calculates the center Y position and then checks each keyframe to see if the distance from the point to the keyframe's location is within a specified hit radius, 6.0 units. If a keyframe is hit, it returns an option containing the property path and the keyframe. Overall, this snippet is focused on detecting user interactions with keyframes in an animation timeline, enabling actions like selection or manipulation of keyframes. This code snippet extends the hit testing for keyframes to include child properties in a property hierarchy. 1. Check for child properties. If the current property has any children, it increments current Y to account for the space needed for the header of the expanded property. 2. Iterate over child properties. It loops through each child property, calculating the center Y position for the keyframes based on the updated current Y. 3. Hit testing for keyframes. For each keyframe in the child property, it converts the keyframe's time to an X coordinate and creates a point for the keyframe's position. It checks if the distance from the provided point to the keyframe's position is within the specified hit radius. 4. Return on hit. If a hit is detected, it returns the property path of the child and the corresponding keyframe. In summary, this snippet efficiently checks for interactions with keyframes of child properties within an expandable property structure. This code snippet covers several key functionalities related to a timeline interface. 1. Current Y position update. If certain conditions are not met, the else block, it increments current Y by row height, effectively moving down for the next potential entry in a vertical layout. 2. Time to X function converts a given time in duration to an X coordinate on the timeline. It calculates the X position by considering the duration in seconds, position spacing per second at the default zoom level, the current zoom level, and any horizontal scroll offset. 3. X to time function converts an X coordinate back to time in duration. It computes time based on the X position adjusted for scroll offset and the scaling factor based on the zoom level. 4. Drag operation enum defines different types of drag operations that can occur in the timeline, such as moving the playhead with a specific X position, dragging a keyframe with associated properties like property path, original time, and starting X position. No drag operation. In summary, this snippet includes logic for managing vertical layout updates, coordinate conversions for time representation on a timeline, and definitions for user drag operations. This code snippet defines an implementation of the view trait for the timeline grid view struct, detailing how this view should behave in a GUI environment. 1. D method returns the unique identifier, view ID'd, for the view. 2. View score style method returns an optional style for the view, cloning it from the view's properties. 3. Debug name method provides a static name for debugging purposes, returning the string timeline grid view. 4. Method responsible for rendering the view. It creates a rectangle representing the background using configuration properties and fills it with a white color. Calls drawTimeGrid CX to render the grid layout. Calls drawKeyframe CX to render the keyframes on the timeline. Overall, this snippet encapsulates the visual representation and basic properties of the timeline grid view within a UI framework. This code snippet handles the rendering of a playhead and hover effects on a timeline. 1. Playhead drawing. It calculates the X coordinate of the playhead based on the current time and the horizontal offset. The time to X function converts the current time to an X position within the timeline. A red vertical line is drawn to represent the playhead, spanning from the top to the bottom of the timeline. 2. Hover effect. It checks if a keyframe is currently being hovered over in the timeline. If a hovered keyframe is found, it retrieves the Y position for the property and the X position for the keyframe time. A semi-transparent orange circle is drawn at the keyframe's position, highlighting it to indicate user interaction. Overall, this snippet enhances the timeline visualization by marking the playhead's position and providing visual feedback on hovered keyframes. This code snippet contains 3 methods that contribute to the layout and updating functionalities of a view in a GUI framework. 1. Compute layout method. Calculates and returns the layout bounds of the view as a rectangle, rect. It uses the view's configuration for its position and dimensions. 2. Update method. A placeholder function that prints update when called. It requests a layout update by calling request layout on the view's ID. 3. Implements the layout behavior required by the view trait, creating a new node in the layout system using Taffy, a layout engine, and returning its identifier. Overall, these methods facilitate proper layout computation, state updates, and integration with the layout engine. This code snippet contains 2 main parts. 1. Scroll_to method, a method that is part of a struct not fully shown here, which takes inputs for application state, a target view ID, and an optional rectangle. It always returns false, indicating that no scrolling action occurs. 2. Timeline handle struct, a lightweight structure that holds necessary references to the timeline's state, configuration, animation data, and its associated view ID. It is designed for managing events related to a timeline view. 3. Create timeline function, a function that creates and initializes a timeline grid view with provided state, configuration, and animation data. It also constructs a timeline handle to encapsulate and manage event handling related to the timeline. In summary, this snippet establishes basic scrolling behavior, encapsulates timeline state management, and initializes a timeline view with its associated handle for events. This code snippet sets up event handling for a GUI component. 1. Handle cloning. 3 clones of a timeline handle instance are created: handle move, handle up, handle wheel. These clones can be used to manage different event types related to the timeline's interaction. 2. Container setup. A container is created which wraps the test, presumably a timeline grid view, and styles it with specific dimensions and background color. 3. Pointer down event handling. An event listener for pointer down events is added. When the pointer is pressed down, it prints pointer down to the console, retrieves the pointer's position, calls the handle mouse down function with the current state, configuration, animation data, and pointer position to manage mouse interactions. Requests a repaint of the view, handle.viewid.requestPaint to reflect any state changes. Overall, this snippet configures a GUI element that responds to mouse presses, updates its state accordingly, and ensures visual updates are rendered. This code snippet defines event handling for 3 types of pointer events on a GUI component. 1. Pointer move event. When the pointer moves, it captures the current position and calls the handle mouse move function to process the movement with the current timeline state, configuration, and animation data. It then requests a repaint of the view. 2. Pointer up event. When the pointer is released, it captures the position and calls handle mouse up to handle the release action. It also requests a repaint, ensuring the view reflects any state changes. 3. Pointer wheel event. This part sets up a listener for pointer wheel events but is incomplete in the snippet. The handling code is not shown. It prints pointer wheel to the console when the event occurs. Overall, these event handlers facilitate user interaction with the GUI component by responding to mouse movements and clicks, allowing for real-time updates to the view. This code snippet handles scroll events and mouse-down interactions in a timeline graphical user interface. 1. Wheel handling. In the event of a pointer wheel action, it calls handle scroll with a specified scroll amount, 0.1, and requests a repaint of the view to reflect any changes in state. 2. Mouse down handling. The handle mouse down function processes mouse down events. It retrieves the current state and checks if the mouse click intersects with any keyframes using a hit test function. If a keyframe is clicked, it updates the state to indicate that a keyframe drag operation has started, storing relevant details including the property path and original time of the keyframe. Overall, these snippets facilitate scrolling and dragging of keyframes within a timeline, enhancing user interaction by updating the GUI state as actions are performed. This code snippet handles mouse interactions for a timeline interface. 1. Keyframe selection. When a keyframe UI keyframe is clicked, it creates a new selection containing that keyframe and updates the selected keyframes in the state. The event propagation stops to prevent further handling. 2. Playhead movement. If the mouse click is within the header area, determined by config.headerHeight, it converts the x-coordinate to a corresponding time value using x to time, updates the current time in the state, and begins a drag operation for the playhead. Event propagation stops in this case as well. 3. Mouse move handling. The handle mouse move function checks if there is an active drag operation. If the operation is dragging the playhead, it outputs moving playhead. Overall, this snippet manages user interactions for selecting keyframes and moving the playhead in a timeline, updating the state accordingly, and controlling event flow based on user actions. This code snippet handles updates for a timeline based on user interactions with the mouse. 1. Playhead movement. It converts the x-coordinate of the mouse position, pos(x), to a corresponding time value using the x to time function, updates the current time in the state, and stops further event propagation. 2. Keyframe dragging. If a keyframe is being dragged, drag operation keyframe, it calculates the horizontal movement, delta x, and determines the new time for the keyframe based on its original time adjusted by the drag distance. It logs the new time for the keyframe, but leaves a to-do comment indicating that the actual update of the keyframe's time has not been implemented yet. Finally, it stops event propagation. Overall, this snippet allows for intuitive movement of both the playhead and keyframes based on mouse input, while updating the state accordingly. This code snippet handles hover state updates and mouse release events in a timeline interface. 1. Hover state update. If the mouse position pause intersects with a keyframe checked via hit test keyframe, it updates the hovered keyframe in the state with the corresponding property path and keyframe time. If no keyframe is detected, it sets hovered keyframe to none. The function allows event propagation to continue. 2. Mouse up handling. In the handle mouse up function, it resets the dragging state to none, indicating that no drag operation is active after releasing the mouse button. This event handling stops further propagation. Overall, this code manages visual feedback for hovering over keyframes and the completion of drag actions, ensuring the timeline state reflects user interactions accurately. This code snippet defines the handle scroll function, which manages zooming and scrolling in a timeline interface based on mouse scroll input. 1. Zoom adjustment. When the scroll delta is non-zero, it adjusts the zoom level by multiplying the current zoom level with a factor derived from delta. The zoom level is constrained between 0.1 and 10.0. 2. Scroll offset adjustment. To maintain the timeline's position under the cursor during zooming, the scroll offset is adjusted proportionally using the ratio of the new zoom level to the old zoom level. 3. Event propagation. If a scroll action occurs, event propagation is stopped. If there is no scroll, it allows further events to propagate. Overall, this function enables smooth zooming in and out of a timeline while keeping the user's focus centered on the cursor position.